All right, let's get right into it. You know, every big journey has a first step, right? Well, in programming, one of the very first things you got to learn is how your computer actually deals with numbers. So today, we're going to pop open Python's Arithmetic Toolkit and see exactly how it handles basic math.
I mean, it sounds so simple, doesn't it? You punch in some numbers, hit enter, and poof, you get an answer. But have you ever stopped to think about what's really going on under the hood? Like, how does the code even speak math? That's the first thing we're going to unpack.
Okay, so to get our heads around this, we first need to learn the language. It's kind of like learning the basic grammar of math inside your code, and it all boils down to just two really important words: operators and operands. Let's look at something super simple: 3 plus 4. In this little equation, that plus sign, that's your operator. Think of it as the verb, the action word. It's telling Python, hey, do this. And the numbers, the 3 and the 4, those are the operands. They're the things the action is being done to. Seriously, once you get that, you've pretty much nailed the basic structure of how all math works in code.
All right, now let's see how this idea applies to the tools you already know and use every single day. I'm talking about the big four, right? Addition, subtraction, multiplication, and division. Now, 3 of these are going to feel totally familiar, no surprises at all. But one of them, yeah, that one's got a little surprise waiting for you.
So you've got your plus sign for adding, your minus sign for subtracting, and that little asterisk or star for multiplication. These are your trusty workhorse tools. Nothing tricky here. They do exactly what you think they're going to do, just like back in math class.
I mean, look at this. 2 plus 3 is 5. 3 minus 2 is 1. 2 times 3 is 6. Easy peasy, right? Super straightforward. But remember that twist I mentioned? Let's get to it.
Okay, so this is where Python does something a little particular, and it's really important to know this. When you use the normal division symbol, that /, you'll see something pretty interesting with the answer it spits out.
So check this out. If you type in 20 divided by 10, what do you expect to see? Probably just the number 2, right? But look, Python gives you 2.0. What's with that decimal point and the 0? Is that a bug? Nope, it's totally intentional.
And this brings us to a super important rule you just have to remember. Python's main division operator is all about precision, so it always gives you back what's called a floating point number, basically a number with a decimal point. It'll do this even if the decimal part is just 0. It's consistent, which is great, but it also means we're going to need a few more tools.
And that's the perfect lead-in to Python's more specialized power operators. Think of these as the precision tools in your kit. They give you way more control and help you solve trickier problems, starting with the one we literally just ran into.
So yeah, that's the big question, isn't it? What if you don't want 2.0? What if your code needs the plain old whole number 2? Well, lucky for us, Python thought of that and has a special operator just for this job.
Okay, so Python actually gives us 2 different division tools. The single slash, we know that one. That's float division. It always gives you the decimal answer. But check this out, the double slash. This is called floor division. It does the math, but then it just lops off everything after the decimal point. It basically rounds down every single time. So if you do 10//3, you don't get 3 point something, you get just 3.
But wait a second. What about the part we just chopped off? What if you actually need to know what the remainder was? Well, there's a tool for that too. It's called the Modulus operator, and it's just the percent sign. It's a cool one because it doesn't care about the division result itself, only what's left over.
Let's break it down with an example. Say we have 15% 7. Here's how Python thinks about it. First, how many full times can 7 fit into 15? Well, twice, right? Because 7 times 2 is 14. Cool. Now, what's the difference between our starting number, 15, and that 14? It's 1. And that's it. That's your remainder. That's what the modulus operator gives you. All right, one last power tool for now. What if you need to do to the power of something? You know, exponents. Now, if you've used other tools, you might be looking for a little caret symbol, but nope. In Python, it's a double asterisk.
So, if you want to say 2 to the power of 3, you just write 2 * 3, and that gives you 8. Simple as that. It's just 2 times 2 times 2. Okay, so we've got our operators, we've got our operands, we've got our whole toolkit. But there is one final, absolutely critical rule we need to talk about, and that's the order in which Python uses these tools. It's called operator precedence.
See, you can't just assume Python crunches numbers from left to right. That's not how it works. You probably remember something like PEMDAS from school, right? Well, Python has its own version of that, a strict set of rules, a hierarchy that makes sure every calculation is done the same way every single time. No confusion.
So here they are, Python's rules of the road. At the absolute top of the pyramid, the first thing Python looks for is exponentiation, that double asterisk. After that, on the next level down, you've got multiplication, division, floor division, and modulus. They all have the same rank. And then, at the very bottom of the ladder, are addition and subtraction. Python will always handle the top-level stuff before it even looks at the bottom-level stuff.
Okay, quick pop quiz. Let's put these rules into action. If you see 2 plus 3 times 4, what's the answer going to be? Think about it for a sec. What does Python do first?
And the answer is 14. Why? Because multiplication is higher on that hierarchy than addition. So Python zooms in on the 3 times 4 first, gets 12, and then it does the addition, 2 plus 12. And that's how we get 14.
So let's do a super quick wrap-up. We've got operators, those are the action symbols, and we've got operands, those are the values. We learned that the standard division with 1 slash always gives you a decimal or float. The double slash floor division gives you just the whole number. The percent sign modulus is your tool for finding the remainder. And most importantly, all of this follows a very strict order of operations.
And look, these aren't just some random rules you have to memorize. These are the absolute fundamental building blocks for everything, from a basic calculator app all the way up to complex scientific simulations. So, you've got the toolkit now. The real question is, what are you going to build first?